In this video, I'm going to show you how to calculate the uncertainty of your step size for the Millikan oil drop lab. Okay? And what we got to do is we got to find a step, and really I think the thing to do is to find the most populous step. Okay? I think that's this guy right here. Okay, so now notice that it starts with 7.38 times 10 to the minus 19th and ends with 8.18. Now the question is, do I keep that little guy there? I feel like I'm not going to do it because, see, I ignored this, I ignored these guys, right? So it's really, I would ignore this if that were on my step. I wouldn't have included it. So I'm just going to use from this guy, 7.38 to 7.90. I think legitimately that's my regime of error, 7.38 to 7.90. So let's find that, okay, in the data. So go into your calculated charges. 7.38 is this guy. And 7.90 is this guy. Okay? And what we're going to do is I'm going to take these guys and make them a little more accurate here because we need to. So I'm just clicking on this thing. Let's get a couple more digits of accuracy on this. Okay? Now, basically, the uncertainty is going to be high minus low divided by 2, and that's the uncertainty for one step. But because we did a calculation that involved looking at 7 steps, we're going to take that answer additionally and divide by, we're going to divide by 7. Okay, so I'll just show you this calculation here. But first we need to grab this. Let's do a screenshot here. This is a Macintosh screenshot. Okay. And let's go to our slideshow here. Okay, now just remember that we did 7 steps here. Okay, I'm going to erase this ink here, and let's escape from here. Let's keep them, and let's paste this. All right, I think we don't need these guys anymore. So I'll just put this guy over here, and then let's what color pen should I use? I'll use blue again. Okay. So here's what we're going to do for the uncertainty. The uncertainty is going to be the high for that particular step. Okay. For this step that we chose, right? We did from here to here. We ignored that guy because we would have ignored it if we'd chosen that step for our step size calculation. But I did from that one to that one. Okay. And the calculation is going to be this. We're going to go high minus low. This is going to be the uncertainty of that step, right? So the uncertainty of the step, of that one step, okay? I'm talking about specifically the uncertainty of this step right there, okay? Up here comes an announcement. All right. Okay. So high minus low, the alarm. All right. All right. Good. You don't need to repeat that. Good. All right. So high minus low divided by 2. So I'm going to go 7.8987 times 10 to the minus 19th. That's this guy, right? That's the highest one, right? Minus the lowest on that step, so minus 7.3803 e minus 19. And then we're going to divide that by 2. Okay, so let me do this. 7.8987 e minus 19 minus 7.3803. And I get 5.184 times 10 to the minus 20th. I'm going to divide that by 2. And I get that step had an uncertainty of 2.592 times 10 to the minus 20th coulombs. That's one step, right? But remember that our calculation involved that uncertainty, but it's actually going to be spread out over 7 risers. So now I've got to take this and divide that by the number of risers that I used, the same number that I used here, okay? So divide that by 7, okay? So divide it by 7, and I get 3.7 times 10 to the minus 21st. Or and that would be 0.037 times 10 to the minus 19th. Okay? Now, if you go back and you look at what our value for E was, we got 1.561 times 10 to the minus 19th. But that is plus or minus 0.037 times 10 to the minus 19th. Now, I'm pretty sure if I add something that's about 0.04 to something that's 1.56, we'll get very close to the 1.60 E minus 19 that we think it is. That's the elementary charge, right? You see that if I add this to this, I'm going to get something very close to that, okay? And, you know, it's okay if we don't, right? I mean, it's a simulation, and I do believe that, you know, I've never seen anybody come in over 1.60, so I feel like the simulation just tends to err on the low side, and that's fine. But anyway, that's how you do the uncertainty. Okay, so just to recap, find the step, the most populous step, okay? And that's going to be the step with the most number of steps on it, right? Find the lowest one that you would have used if you had averaged that step, and the highest one you would have used if you had averaged that step, right? So these things, like you would not use that one. Nobody would use that. We wouldn't use those two. We wouldn't use that, right? So just there it is, right? Okay. Average those. Find them in your sheet, right? And then notice what I did was I actually gave it more digits so we could be a little more accurate. And then you're going to go the high minus the low divided by 2. And then you take that and divide it by 7, because that uncertainty is actually spread out over 7 steps. All right.